Alright, welcome to the video about logs. It is the most boring piece of media you're ever gonna see in your whole life, so you better get some coffee if you wanna stay awake. Just letting you know. So, let's talk about logs. First of all, we need to understand what logs actually are, so let's go back to the very beginning, the definition of logs. And if you wanna say,
I know what logs are, go away.
well, no you don't, at least for the purpose of this assignment. Alright, so what are logs? Logs. Not these logs, the logarithm logs. Long story short, logs tell you how many times you multiply a over itself to get your b. Meaning, to what power do we raise a to get a b? Sounds really simple when put that way, right? So if a is 1... Oh wait, I'm not allowed to show examples or else I'll fail. Never mind. Let's instead have a look at these problems. What does look similar between all of them? Yeah, except for that. So all of them are logs of x. If you remember, we need to find this x. Not exactly sure why and what profit does this yield, but whatever. So we're gonna call this our first pattern. To solve it, simply raise a to the power of b and you'll get the x. On to the next pattern. This time x is the power, so how do we find it? Well, we could try to calculate it in our heads, like if a is 10 and b is 100, our x will be
2,000 years later.
And our x will be 2, because this is how many times you need to multiply 10 over itself to get 100. Or we could just use our calculators. Just like that. Now let's rest for a moment and take a look at the logs and their natural habitat. Not exactly an exciting view. Anyway, let's continue with our patterns. This is our third pattern, and it looks slightly more complicated than the previous, right? Well, that's only because it is. But worry not, we can solve it. Remember what common logarithm is? Well, look at the b plus x as a result of raising a to the power of c. This way, we are left with a simple equation and not a sign of a log.
Lonely, I'm Mr. Lonely.
Yeah, so this pattern also has a sub-pattern, and it looks even worse. How do we solve this? Well, first of all, we have to remember that logarithms are exponents, which means we can break them down in various ways. For example, the log of a product is the sum of the logs. The log of a quotient is the difference of the logs. Knowing this, we can simplify our problem and then reduce the log.
And it's gone.
And then solve it as any other equation. These types of problems are predominant in our book and in exercises 31 to 57 in particular. Although there are 2 more types we haven't looked at.
I thought it was almost over.
Yeah, what a naive creature. You might have noticed that we classify our logs by the location of x. We've already seen problems with x as a power and x as a value. But what about x as a base of a log? These problems are the easiest ones. Since we know the power and the result, we can simply use the root to find our base. Last but not least would be an x as a power of value. This particular one can be solved in a number of ways. The easiest way would be to use the definition of a common log again and then solve for x. God, if only I knew all this when I was doing the test, I wouldn't have failed. Well, as much as I enjoyed it, it's time to wrap it up. Caesar, would you please read the statement for us?
Based on the properties these patterns already provided by the text are the basic models of what is stood in my face when solving logarithmic equations.
Well, I think this is true because first of all, most of the problems already look like the ones displayed. If they don't, they can be simply reduced or simplified to these forms. Unless we're talking about some ridiculously complicated logs that strive to take over the world. But I really don't think so. I think we should be able to solve some of the simple logs on our own now. Alright, thank you for watching, hope you enjoyed it, my cat sure did not.
I hate you, Maxim.